Okay, so thus far this semester, we've gone over the basics of C Sharp. We've gone over data types, we've gone over variables, user input, we've gone over arrays. We haven't talked about lists very much, which are similar to arrays, and you'll see what the differences are as we talk today. But we talked about arrays a little bit. We've also talked about classes and methods and functions, right? Methods exist inside of a class, functions are external from a class. Talked a little bit about that. Now, the stuff, we also did some Unity stuff as well. Now, classes are a little advanced for C Sharp 1, but I do always like to bring them up in both interior programming and C Sharp 1, just so you all have an idea of what it is that we're talking about, okay? Now, the real work, if you will, begins next semester in C Sharp 2, when we really take some deep dives into, we learn about a technology called link, okay, which has to do with getting and manipulating data, receiving and accessing and manipulating data. We'll talk about multi-threading. We'll talk about parallel processing, different things like that. And we'll get into a lot of graphical stuff in C Sharp. We'll start actually playing around with how to make a graphical application using Visual Studio and things like that. We've done a little bit of graphical stuff with Unity, and we'll do a little bit more with Unity and a teeny little bit of it next semester. But we'll actually start really learning how to do visual stuff in Unity, or excuse me, in C Sharp and in Visual Studio, as opposed to just using a game engine to kind of manipulate stuff, right? We're going to let our IDE do a little less heavy lifting for us, okay? So the first video we're going to watch here, this is from the official .NET YouTube channel, which is Microsoft's one of Microsoft's many YouTube channels talking about their technologies and things like that. This first video is about arrays, lists, and collections. Now, I want you to pay close attention when they start talking about what the differences in an array and a list is, because that's very, very important. Does anyone want to venture a guess? We want to raise their hand and just take a stab in the dark as to what they think the difference in an array and a list is. It's okay if you're wrong. I'm not gonna like make fun of you or anything. Just like, does anybody just want to just guess? Take a shot in the dark. Come on. Somebody guess. What do you think the difference in an array and a list might be? There's one big major fundamental difference. Let's say it like this. A list would be best used if I were building a high scores list for a game. Be better to use it than an array. Any thoughts now? Yes, sir.
Is it ordered?
No, that's a really good guess. That's a super good guess. Any other thoughts? No? Anything? Okay. Well, let's watch this video then. Here's the thing about it. As soon as it's revealed to you, you're gonna be like, oh, okay. But yeah. So let's get going on this and learn about arrays, and then talk a little bit about lists, and then we can move on and do some talk about some methods and things that we can do on arrays.
We just spoke about combining branches and...
Sorry, there's one other thing I wanted to mention before we start this video. If you've not seen any of these videos before, any of the videos that feature this guy, this Scott Hanselman guy on the left, he's a super great guy, really smart, knows C# really well. He's not the world's greatest presenter. Thankfully, this girl's a little better than the one that he has helping him with with advanced C# stuff. It's kind of weird because she's a really bad actress, and so she's trying to like say pre-written lines as though they're like just coming to her, but she's like saying them anyway. So my apologies. Anytime we watch this, like the official Microsoft.net stuff, it's not the most entertaining video in the world, but it's incredibly informative. So sorry, I just wanted to put that little disclaimer out in front.
Loops, and now we're going to talk about arrays, lists, and collections in C#.
So I'm going to switch back to where we were before. We were just working on our
branches and loops. Click on arrays and lists. And we're going to go through this basic list example. Now they're telling me to make a new application, but because I know now what Hello World looks like, I can just delete that one and keep reusing my same application.
Definitely.
Okay, and I'm going to take just the code inside of the main here and put that over here, and let's take a look at what's going on.
Yeah, it should give you, there's a little error.
Yeah, this is interesting. So we're saying var, which I've never seen before, and then new list. So there's actually two things that are going on here. Why don't we fix that one, and then you can explain this one here.
Sure. Yeah, errors always get the priority.
Oh, yeah.
So actually, if you see a little light bulb popping up in the margin, there it is. Why don't we go ahead and expand that? So this is recognizing that this type, rather, right now it's a collection of a generic type, isn't imported. So remember, we were talking about using statements being namespaces that you could use the types of in your program.
Right.
This is just warning you, hey, you need a system.collections.generic import statement at the top of your file.
Okay, so if I didn't have using system, it would complain that console wasn't there because it's system.console.
Yeah, you get a similar error.
And list is a system.collections.generic.list. So I can just go like that.
Yeah.
And look, it put that in there for me. It typed that for me. And this now doesn't squiggle.
Yeah.
Which is pretty sweet. Okay, cool.
So those little light bulbs are often really great hints for if anything's going wrong, should be able to help out.
Right, there's lots of light bulbs. Another light bulb that's popping up here is we're saying for each, which we haven't learned about yet. But there's a light bulb there that's saying you should be explicit. You should be very specific instead of saying var or var. What is var doing here?
So var, I am a pretty big fan of var. Var is what you put when you do not know what this variable is going to be.
Nor do you care.
Yeah, nor do you care. So you can just start typing, and so it's great. So if I did var, do you want to create a var, var int var I equals 0?
So we've been doing this. We've been making ints all this time, right?
Yeah.
So if I go var I equals 0, and I go I dot, I'm getting inty things.
Yeah. So if you hover over I as well, I think it'll actually indicate that this is an integer.
It is.
So this is just our compiler automatically inferring that because you have a 0 on the other side, they're just saying, I'm going to guess this is going to be an integer.
Yeah, but if I go and say Scott, and I hover over it, it immediately knew that it was a string. And if I say I dot, look, trim end, those are our stringy things.
Yeah.
So var is cool if it's like, I don't really know, I don't really mind. So I could say, and this is where it gets really useful, list of string called names. But now I've said list string twice, and it's kind of giving me a headache, and it's just faster to type var.
Yeah.
And you might find
shorter,
that people might not like that because it's a style thing, isn't it?
It is definitely a code style thing. So this is also something you can configure in Visual Studio to prefer var when the explicit type, that being the list of string, is apparent, meaning it's just obvious what this type is. We don't need further explanation.
Yep.
And use explicit type in all other cases. And that's what it's set to now. So if we look at the var, the squiggle under the var in the for each loop, it's saying that, hey, it isn't super obvious what this is.
That is a good point.
It
It is obvious here. It's kind of not obvious there.
Right. Just in the for loop, there we go. Just in the for each loop, we now have a string.
Okay. So here we're saying with our list of names.
Yeah, definitely personalize this list. Much better now.
Very important. So we're saying for each of those names in names. And this is very common, this singular and plural. That's not required. I could call names foo, and I could say for each name in foo, but it's kind of nice to say for each name in names.
Yeah.
For each product in products.
So names is my list, and when I'm going through my for each loop, I'm choosing one item in that list and storing it in that name variable. So we had iterators and indexes in our last examples, or like counters, and those would naturally increment every time the loop executed. With for each loops, it'll just grab the next item in that list. So it's a good way of transforming anything in a list.
That's a good question, actually, that I'm having in my mind here. Let me ask you this. Would it be okay if I did this? Could I do this?
Names length Yeah, I think I see where you're going.
Right?
So,
And then I could take this console.writeLine, and could I say name I?
we want to use
But
names.
I see I can't. I got to go names I, right?
Right. So
That got a lot more complicated. I get it, but it's not as nice to read as that, is it?
right. So you're using the I index to tell the for loop, or to tell names which item in the list you're grabbing. So
Right.
it could be the first or second, third, whatever.
So we're digging out the 0th, the first, and the second, but that is a little harder
it's
to
more,
read.
Definitely.
I just want to go through the list. I mean, I can do that, but isn't it nicer to do it the other way? But the nice part is that we can do it either way.
Yeah, definitely.
Yeah, definitely. So let's switch back over here. We can go, and actually, we should see if it works. Let's do it both ways, because who knows?
Oh, yeah.
It did work. So this is really important to point out, because it not only worked,
All
but it in
caps.
fact worked both ways.
Yes.
So it is showing you that they're kind of the same, but you want to use the one that makes you happy and the one that means what you want it to mean. So that's a good reminder.
Definitely. Another sort of just style thing. One of the things that's really fun about programming languages, it is very much like writing style, just how certain authors have different writing styles when they use English or when they're writing different books. C# is very dynamic and kind of personalized.
Yep, that is a great point. So let's remove all of that, and we'll just start with our list of names. And one of the things that we can do is we can say names.add. We can add our friends to that list of names. I'm going to say names dot. These are all the things that a name can do. We can add and it can remove. Okay, and then I can say names.remove, and let's remove me, because I've left. And then we can go and do that for each again, for each name in names. And then we'll say console.writeLine. And let's just go and print out, we'll just print out the name again. Is that cool?
Yeah.
And then again, I can decide if I want to make that a string or just a var. Totally up to me. I'll leave it as a var and see if it works.
Okay.
Yep.
Cool. So you've been able to actually remove and add items to the list of string. What is list of string? What is that syntax?
Yeah, isn't that interesting? That is called generics. So if you're out there searching the internet and you're finding out what's going on, you read that as a list of string. And list, they say, can be of any type. And they usually say it can be of any type T. I can have a list of ints, or a list of string, or a list of pants. So this is actually a programming joke that you taught me. You can have a cup of tea.
Because it's a cup of type T. Okay, yeah.
That's your
It's a
first
cup of
programming joke in C#. If you like that, then you should be a programmer. There's a lot of nerd humor available in the programming industry. So definitely just casually drink your cup of tea and see if anyone else notices, and I think you'll be a winner. Yeah, and then just at the end here to point out the indexing part that we did, I can say names, and I can put it into a bracket there. We talked a little bit about brackets and arrays when we talked about args.
Right.
When you explain that, I could say, give me the 0th or the first name. So let's do this. Console.writeLine. Notice how I spelled those wrong, and it's going to squiggle on me, isn't it? It's got to be spelled right, and it's got to be uppercase and lowercase correct. So what is names at 1? It's not names of T, it's list of something, and it's names at 1. I would expect that would say Scott.
Yes. So that's another thing to call out.
It does not. Why not? Trick question. I removed myself.
Oh, you did remove yourself.
Yeah.
Ooh.
Yeah. So I removed myself, and you are the first one now. So imagine we had name, which is just words, Scott, Kendra, Maria, Bill. We removed me. That shifted you up to the number 1 spot.
Yeah.
So now you're
like
number
it.
1 in the names list.
So speaking of the number 1 spot, what's in the 0th spot?
That is a weird spot. I'm actually going to change that, and we'll just say that that's weird. We'll have a spot that's called weird. It's the 0th spot, isn't it? It is this, everything in an array is 0 based. 0 is the first place. I don't know why. It's always been that way.
It's kind of a big characteristic of programming languages, whether or not they're 0 indexed or start at 1. So C# is 0.
Yep, and there are other languages that are 1 indexed, but you just remember that that's the first spot is the 0th, the second spot is the first, and you go from there and you'll be fine. And those are some of the errors that you'll find as you go and play with lists, is you might be off by 1. And that's okay, because you'll be able to write it and try again. All right, so that is a little bit of an understanding of lists and collections. Let's take a break, and we'll come back and talk about how to search them and sort them.
Okay, so back to my original question. What is the big major difference between an array and a list? They didn't say it explicitly. Any thoughts? Okay, huh?
Arrays are fixed size.
Yes, exactly. Arrays are a fixed size. Okay? Do you remember in the reason I showed you that video on how to do sound in Unity was because he uses an array to hold all of his sounds. Now you're probably thinking, well, now hold on a second. He added more sounds as he went. He started with 1 sound and he added more. How is that possible? Well, because they hadn't compiled the code yet, right? As far as Unity is concerned, that code is still in raw form. It hasn't been compiled yet, right? And so you can still, you're still in edit mode essentially. You could, within the engine, until the game is deployed, you can continue adding more sounds, right? You could also alter the data in an array by accessing its specific index, right? So if I want to change the 0th element in an array, I access it with the little square brackets and a 0, right? My array or whatever brackets 0 equals, and then I can change that value, right? But I cannot alter the size of an array after the program has been compiled. So if I was making a game and I wanted an inventories list, would I want an array or a list? It's an inventory. Should be an array or a list?
Probably a list.
Yeah, why?
Because it's not like a predefined amount.
Yeah, I might end up collecting more of something than the game developer themselves did in testing and things like that. So yeah, you want to use a list. Perfect.
All the cheese wheels will start.
What's that?
Like all the cheese wheels will start.
Exactly, yes. So there are lots of cheese wheels, and so you wouldn't want to say, well, it's going to be an array, and then, oh man, there are 50 more cheese wheels to collect, and we cannot collect them, right? You wouldn't want that. So yeah, they are of a fixed excuse me, size. Now, let's talk for just a second. This isn't really to do with arrays and lists necessarily. It's more to do with loops. But let's talk about a for loop versus a for each loop, right? They showed an example of how you could do that same thing in 2 different ways, right? To for each, or the for where it starts at 0 and increments it every time. Now, which of those 2 was easier to read, the for loop or the for each loop? Which one visually makes more sense when you look at it? Yeah, for each. Because, like, okay, think of the example they gave. For each name in names, remember when I talked about for each loops at the very end of last semester, right? I talked about, okay? The reason I want to bring this point up right now is because I want to talk a little bit about best practices for a second. Now, they said in that video, oh, just do whatever feels best to you. Do whatever you want, man. I tend to disagree with that, right? I tend to be a proponent of best practices, which is to say, yes, there may be 10 ways I could do this, but there is one way that makes the most sense. Which doesn't say the other ways are bad, they're just not the best, right? Okay. And so, so make sure that you're using for each loops, just because, like, especially when it comes to the idea of a list, if all you're wanting to do is just cycle through them and, like, for, like, if you wanted to print out what was in your inventory, for each item in inventory, print item, or whatever, something like that. So that's just the best way to do it. Not the only way, not the be-all, end-all way, but what we consider the best way. Now, once we have made a list, we can sort it, we can search it, we can index it, right? Why might we want to sort or search a list? Let's start with that first one. Why might we want to sort a list? We've already been talking about it in this class, in this session.
I mean, if it's a list of names, I mean, maybe you want to sort it by like last name or
You
first
might.
name.
You might. What else? Well, I mean, another example when you might want to sort a list.
Makes it easier to search it.
It does. It does. It also makes it easier to manipulate it in certain ways. To use the high scores list, for example, in order to determine if a score makes the high scores list, you need to sort it first. Because you need to determine, is that number higher than the lowest high score? Because if it is higher than the lowest high score, then it should be added to the list. The list should be resorted, and the now 11th thing in that list should be removed because it is now no longer the 10th highest score. It is not the 11th highest score, and we only go to 10, right? Okay, so let's talk about searching, sorting, and indexing lists.
So we just covered lists of strings in C#. Now we're going to sort, search, and index these lists.
Let me switch back over here. I've got my tutorial on the left and Visual Studio on the right. And when we last left our heroes, we were saying names at 0. And we noted when we ran that, weird, who's our weird friend, that weird friend is the 0th item. So it's they called it the index of that.
Right.
So that's kind of weird.
So let's dive in a little bit more into indexes. It looks like our docs are saying there's another way to access an index.
Yeah, so we could go and say var and grab an index and say names dot index of. So I can actually ask the array or the list, the collection, hey, where is Kendra? What is the index of Kendra? So it's actually going to search for you in that list. And then I'll go and console.writeLine index. Maybe I could even go like this and I could say found, well, I guess I'll just say Kendra because I've hard-coded you here, at index. Okay. Oops. Always a little syntax here and there. There we go. Let's try that. Sound like a plan?
Yeah.
And we'll get rid of our weird friend there. Control F5 or hit the play button. Found Kendra at 1. So 0, 1, 2, 3. Oops, there's Bill. And just to confirm, found Bill. I expect to.
Right.
No.
0,
1, 2, 3.
Oh.
There we go.
Okay, yeah.
Forgot about Maria there. Yeah, that's my bad. Now, what if we search for someone that doesn't exist?
Ooh, I don't know.
Let's search for Scott, who we have previously removed, right?
Yeah.
So index of Scott.
-1.
Now it says found because I wrote the word found, but it didn't actually find it, right? So that's interesting. Now we can combine that, as we see in the sample here, with an if statement. If index is not found, else. So why don't we try that? That's interesting. I'm going to copy that code in here, and I'll make it a little bit bigger. Oops, let's put it there. So if index is -1, when an item is not found, index returns index. Else, the name, and this is interesting, look.
Is that index?
Names at index, we're going to take the index that we just grabbed, so this is the number of where Scott is, or not, and then look it up, and then print that out. So what do we think is going to happen? Is Scott in there or not? When an item is not found, index of returns -1. But if we go in here and we put in Kendra, we do it again. Ah, so let's look at that. The name, names at. That's how I think of that. So we saw that cup of tea with the less thans and greater thans, and then when you're doing a list or an array, it's at, which is the square brackets. Make sense?
Definitely. So now we know how to find the index of where something is in an array. So that's a type of searching.
Right. Let's sort, because we've been right now just putting these in whatever order, right? We'll put me back in, so I'm not going to remove me right now.
Good. I wanted you to be included.
I appreciate that. And I'm going to go and have, right now, our original list. We'll change weird to new friend. We've got new friend, Scott, Kendra, and then we are going to manually or programmatically add Maria and Bill.
Sounds good.
Then we're going to spin through our list just to confirm what that looks like.
New friend, Scott, Kendra, Maria, Bill. Yeah.
Okay, cool. Looks good. Now they're telling us sort the array. Now this is an interesting thing because I would have thought that I would have to say names equals names.sort.
Yeah.
Right? Because I did replaces before and I did different things.
Yeah.
But in fact, sort does it in place, right? It sorts it on the spot. It doesn't make a copy of it, which, you know, might not be intuitive if you haven't seen that before. So let's see what we get when we sort our people.
Oh, cool. And it just knew to sort it alphabetically? How did we know that?
Right, that's a great question. So if we hover over sort, we can ask that question. It says, using the default comparer.
The default comparer, of course.
Of course,
What?
comparer. Well, so it turns out that this is a list of strings, but it could be a list of T. It could be a list of anything. So when you compare strings, you know, like is this string less than this string? You actually have to do that. You can say, is the word Bill less than the word Kendra?
Right.
And because Bill comes before Kendra in the alphabet, Bill is less than. It's less than in air quotes. So that's the comparer, and that's how they sort.
Even without air quotes, because each character in a string does have a numerical value.
That's true.
So like A is a very low number. So even if the string was converted to a number, sorting them would still have, you know, smallest at the top, biggest at the bottom.
That's a really great point, because if this was, because remember we talked about strings. Strings is a friendship necklace.
Right.
It's actually a friendship bracelet or necklace of characters, or what they call chars, and those chars have numbers.
Yeah.
So yeah, you could sort the characters within a string, and that would be something as well. That's a really great point. I didn't think about that. So when we go and do something like this, we can look at a larger example. Here's a bigger example that you could mess with. And actually, you know, well, let's do this. Let's just copy that whole example.
Ooh, yeah.
And I'm just going to go and Control A for all and Control V for paste. And let's just kind of zoom out a little bit. Got a whole big example here. Let's run that. So we can see in the tutorial all the different things that they've done, where we've removed names, added names, sorted names, seen them move around. This is a great little example of all the different things you can do with lists of stuff. But in this case, we've only talked about strings. So let's take a break and we'll come back and we'll add other types, other stuff of T to our lists.
Okay, so a couple of quick things. I have to move back. I just lost my train of thought. I'm sorry. That's why I write things down behind me so I don't forget them. Whenever she was talking about that even if we converted all of those names to numbers, right, based on the numerical value of each letter, Bill would still come before Kendra because B is a lower number than K, right? That starts to become really important as you move forward it's really important always, but it becomes especially important in two specific areas. Area number 1 is web development. Area number 2 is mobile app development. Does anybody want to wager a guess as to why?
So, I mean, I kind of heard something like basically, like, computers handle strings weird compared to, like, integers, I guess?
Yes, correct. And strings are made up of what?
Characters, text.
What was the first word you said?
Characters.
Which are also known as? They just said it a second ago. Chars.
Chars.
Right, right, okay. Now, here's the interesting thing about chars. Chars are represented. Okay, do you remember when we did the your name in binary project at the end of last semester, right? Names are also, excuse me, characters, chars are also represented in what we call Unicode, right? Now, here's the really cool thing about Unicode. So, all 26 letters of the alphabet, actually 40, however many, it's 50, whatever it would be, because it's upper and lowercase both. So all letters of the alphabet, both upper and lowercase, as well as 0 through 9, as well as your punctuation, and so everything that are on the number keys up there, all that stuff, all the symbols that you see, as well as things like trademark, copyright, a few of the different ones like that, are represented in Unicode, which means that I can tell the computer to reference the image, basically, that represents that particular character. Now, the other thing that is related to Unicode is emojis. Emojis can also be accessed in the exact same way. So this is going just a smidge beyond our scope here, but just bear with me here for a second. So, if I want to put a pizza emoji into my website, for example, we'll talk about this a little bit either tomorrow or Tuesday, depending on when you have me for web dev. Or excuse me, today or Tuesday. If I want to put that pizza in there, I don't have to go acquire the emoji of the pizza. I just find its Unicode code, and the web browser will replace it with whatever Firefox's default pizza emoji is. iOS also does that, so does Android, so does everything else. Windows has its own default one, macOS has its own default one, right? So just something fun to think about, that when it comes to strings, and you're correct, they do handle them weirdly, differently, because they're not numbers, right? There are only, if you think about it, there are only how many numbers? 10, right? There's only 10 numbers, 0 through 9, right? So whereas when it comes to things that are not integers, how many booleans are there? 2, true and false, right? But when it comes to chars, there are literally hundreds and hundreds, and if you start including all the Unicode characters and all the emojis, you have literally thousands of characters, right? So just something to think about, the way that that strings and chars are handled within lists are simultaneously identical and very, very different, right? So just something to bear in mind in that regard. Okay, so let's talk about lists of other types. So far, we've just been talking about lists of strings, but you can have a list of anything that you want. So let's talk about some of those.
All right, we've been putting things in lists. We had strings in lists, but we can also make lists of anything. Like we talked about a list of T, where T is any type. Let's put some other stuff into lists. So I'm going to switch over back to my tutorial. I've got Visual Studio on the right, I've got my tutorial on the left, and let's put lists of integers together. And this is interesting too, because we're actually going to put stuff in the list right off the bat, just like we did when we put in lists of strings. So let's delete a bunch of code, shall we?
Right.
Put it back the way it was. We're going to start from scratch. So I'm going to go and delete all this down to there. Hello world.
All right, back where we started.
Back where we started. You can make a new project if you want to. And then I'm just going to copy paste there, and I have Fibonacci. Fibonacci. What is Fibonacci?
Fibonacci sounds pretty fancy.
Mm-hmm.
So,
Okay, before they explain what Fibonacci is, raise your hand if you know what they're talking about. Anybody ever heard that before? The Fibonacci sequence? Is anyone familiar with that? Okay, what is it?
I have no clue. I've heard of it.
Yeah, before Tony tells you what it is. Anybody but Tony know? No? Okay, go ahead, Tony.
Fibonacci sequence is a sequence of numbers that you just add the previous number to. So you start with 0, add 1. So then you add 1 to 1, you get 2. You add 2 to 1, you get 3. Add 3 to 2, you get 5. And then it just gets bigger and bigger from there. Instead of just going down numerically, it just gets bigger. So 5 to 3 is 8. 8 to 5 is 13. 21, 34,
Yeah, I'm actually, that's a great explanation. I'm actually glad that you said pattern because that's actually true. It's actually not so much of a sequence as it is a pattern because technically speaking, you don't have to begin a Fibonacci sequence at 0. You can begin it at literally any number, provided that you follow the pattern of adding each subsequent number to the number that precedes it. Now, here's a really cool thing, and this is not relevant to what we're talking about today, really. But one neat thing about the Fibonacci sequence, it actually occurs in nature. Sometimes it's known as the golden ratio, and it's or not. No, it's a totally different thing. Sorry, forget that I said that. It occurs in the shell of like the nautilus. So if you take like a nautilus shell, right, which they start in and curl out, if you measure the distance between the innermost point of the shell to the first loop that comes around, and you do it for each one, they progress in a Fibonacci manner. That each one is the distance. The next distance is the previous one added to the one before, if that makes any sense. Yeah. So anyway, Fibonacci sequence, pretty cool. Not really relevant to you if you don't do anything with math, but still neat to know about.
It's a sequence that came out of a pattern for that specific type of thing. It was found because of the nautilus shell and stuff like that.
Yep. Yep.
That sequence of formula, basically.
Isn't that crazy to think about that like something like that exists in nature? Anyway. All right, let's move on.
Fibonacci is basically just an algorithm. So if the Fibonacci sequence is where the first two values of the sequence are added together, and that creates the next number. So it could basically go on infinitely. So if you start with 1, the next number would be 2, the next number would be 3, the next one would be 5, next 8, and so on and so forth. Oh, and you can even look up the Wikipedia page. There's actually a ton of interesting stuff to look into, like the Fibonacci spiral,
The golden ratio.
the golden ratio. So I'm a huge geek about the numbers. But if you look into it, there's actually a lot of things like in nature that mimic the Fibonacci sequence, which is just super cool. So anyway, let's show how to show it in code.
Yeah, so there's lots of ways to express this. You might, if you've taken a programming course before, they might ask you to do a Fibonacci sequence. There's lots of ways. So this isn't the way, it's just a way, and it's fun for us to do it because we're learning. We made a list of ints. We put 2 ints in them, the first 2 numbers of the Fibonacci sequence.
Yeah.
Right? And then I can take this code here, and I'll paste that in. And let's just take a look at what's going on here. Here, we are going to look at the previous and the other previous. And this is interesting because we're actually taking the length of the list minus 1. Now, is that the last number or the one before the last number? Remember that lists are 0-based, so that can be a little confusing to new people.
Right, so it should be the last number.
Right, which isn't intuitive. If I go and say, give me the list at the end, I might think I would get the end, but in fact, I'm going to go 1 off the end.
Right, so that's because you have, in your Fibonacci numbers list, you only have 2 elements, and that dot count will return 2, but the index is 1 off because the index again starts at 0.
Right.
So the indexes of your 2 elements are only 0 and 1. So anytime you want to grab the very last element in the array, you need to look at the dot count, which is again the total number of elements you have minus 1.
Right,
And that'll
so
give you the last index.
it says the index was out of range.
Oof.
It must be less than the size. So count is the size. So we need the number that is less than the size, right?
Right.
So what you said was 1. And then we want to get the last 2. So we're going to kind of jumping backwards, go get that one as well. And then we take the last 2 numbers, in this case 1 and 1. We add them together, like we've added before. We've added integers before. And then this is the cool part. Then we add it to the list.
Yeah, so it's continuing the Fibonacci sequence.
Right. So in this case, we then spin through it with a for loop, for each loop rather. And you'll note that we didn't put our curly braces around it because we're just doing 1 line. So that's fine for now. And then let's see, we should see 1, 1, 2.
Yeah,
So that worked.
looks good.
Okay, so challenge time.
Challenge time. The next part of the doc has a challenge, and that's to basically print the Fibonacci, generate the Fibonacci sequence of the first 20 numbers in this sequence.
Okay.
And we have a hint. So we know the number we're shooting for is 6765.
Okay, so that's our final number, the 20th number, then we did it right. Now again, some of you may be advanced, or you may be sitting with someone who's advanced, and they may be saying, well, this is not very efficient, fancy. Well, it's not very efficient or fancy, but it's fun, and it's a great way to exercise our ability to play with lists in C#.
Definitely.
Yeah. All right, so the first 20 numbers in sequence.
Yeah.
Well,
so,
I know that's where we started, right? And that one's
yeah.
allowed.
Yeah, we should keep that.
Okay.
And then we just need to get the next 18 numbers, I guess.
Well, we could do a for loop. We could do a while loop.
Well, sounds good.
Okay, so while it is the case, how do we know if we have 20 of these?
Let's go ahead and use the Fibonacci numbers.count so we get the size of it.
Okay, so this is a list that's going to keep getting bigger.
Yeah,
And when it gets over 20, if it gets to 21, then we're done.
right.
Okay,
so
cool.
the 20th time it executes will be the last.
Okay, cool.
Cool.
And then let's take these things here and let's put them inside because we need to do that 20 times, right?
Yeah, sounds good.
This is
so
interesting.
we're going to be adding a new element to this list with every single time we iterate through.
So this is interesting. We're doing a loop on a changing target.
Yeah.
So this thing's going to get bigger and bigger and bigger while we're standing on top of it.
Mm-hmm.
Yeah. So first time we run it, it's got 2 items in it. We grab those 2 items relative to the end.
Right.
Yeah. Make it bigger. Go through again.
Mhm.
It's got
now at 3
now.
Yeah.
Grab the last 2, add them, and now it's 4. So this could get big, and this could, remember that time when I did a while loop and it filled up
Went
a
on
short?
forever.
I might be afraid that I'm going to go too far.
Yeah.
But
we've got our count limit on it.
Mhm.
Should be less than 20.
all right, let's see if we can do it. Control F5.
Hey,
Brrr.
6765.
Whoa, we got it on the first try.
Nice.
Winning it live.
That's why they make
Interesting.
us do these videos.
This is true. And actually, just to point out, if we said less than or equals to, which might feel intuitive
Right.
to you, right? That went
Ooh.
1 additional
Yeah.
because the size of the thing was 20. We kept going, added the 21st, and then we stopped.
Mm-hmm.
So these kind of errors, wouldn't you say that's the most common error? I mean, my life is just off by
Yes.
1 errors.
Off by 1 is so common. So if you
Mhm.
run into that, you are not
Don't feel
alone.
Don't feel bad.
We do it today, every day.
All day, every day. So just something to think about. And there's lots of ways to solve that. Like if you feel that it's less than 20 or less than or equal to 19,
See?
whatever reads best to you.
Yeah, also a totally valid way to write
Yeah,
it.
I think you and I agree that for us, that feels like a good way to write
I
things.
like nice round numbers.
Yep.
So we just learned a little bit about the Fibonacci sequence. Now we're going to take a look at the debugger.
Okay, we'll start talking about that next time. Okay, so thus far this semester, then we have covered the basics of C#. The array, or excuse me, lists and arrays are pretty much the peak of basic C#. Now, that does not mean that we're not going to start talking about objects and methods here in a little bit. We already talked about some. We'll talk about them more. But I want us to kind of pause now and sort of try to master, if you will, these basics. So this final video that I want to show you here is called Learn C# Basics in 10 Minutes. There's a couple of things he's going to skip over, or not skip over, but he will say, you know, hey, this is a little advanced, so don't worry about that for right now, kind of stuff. And that's fine. That's what I want. Now, go ahead and fire up Visual Studio if you would like. So you can follow along. Now he does do quite a bit of deleting as he goes. So like he types really fast. He speeds that part up, so you're not gonna be able to type as fast as he does because it's like literally like lightning speed. But when I say he does a lot of deleting, what I mean is he'll write like, you know, console.writeLine hello world, and then for the next thing he does, he deletes that and then puts something else in. My advice to you would be to just not delete anything, just add new lines as we go. Now, you don't have to work along with him. I just feel like it's probably going to be easier for you to do so because I'm going to ask you to do something very similar to what he does. So this would be a good jump start on that. So let's check out his video.
In this video, we're going to learn C# basics in just 10 minutes. Variables, ifs, functions, classes, and more. Alright, let's begin. Okay, so let's learn the basics on how to write C# code. Now, the first thing you need is somewhere to write and compile your code. The easiest way is simply to use Visual Studio, which has a free version. Creating a simple console app is the easiest way to start playing around and writing some C#. Okay, so when you do, you have the basic starting file with the main function, and you can press the start button up here to run your code, and as soon as you do, the code compiles and yep, it runs, it opens a window and it closes. Now in this channel I cover game development in Unity, which runs the code pretty much exactly the same, except it does it in a game engine rather than a console app. Alright, so let's write some code. Something that you will use all the time is simply printing a message, so you can do that by accessing the console and running the writeLine function, and then just write something. So just like this, and hit compile, and yep, it runs the code, it prints a message, and it closes immediately. Now you can stop it from quitting instantly by adding a simple console.read key. So run again, and yep, there it is. Now the console doesn't close instantly, so you can easily verify the output. Okay, now one of the core fundamentals of programming are variables, which are containers of data. So to define a variable, first you write the type, then the name, and then optionally you can initialize it with a value. So this variable is of type int, it's named I, and has the value 56. There's a multitude of types you can use for your variables. So you have ints for whole numbers, you have floats for floating point numbers, double is also a floating point number but with more precision, bool for Boolean logic, so values like true and false, char for a character, and string for a string of characters or text. So those are the basic types, and you'll learn more as you go along. You can do a simple string concatenation with plus. So for example here, print that message, then plus the I. And yep, there's the output printing our variable contents. Another fundamental building block are functions. So you define a function by first writing the return type. Now if you want to return nothing, you can simply use void. Then you write the name of the function, and then you add parameters within the parentheses if there are any. So this function here returns nothing and takes no parameters, and this one takes an int parameter and returns a boolean. To use a function, you simply write the function name and then the parameters inside the parentheses if there are any. This is related to the fact that we are calling a non-static function from inside a static function. Statics are a bit more advanced, so don't worry about them for now, but in here you can simply fix it by making these two also static. So you can call a function like this, or our second function, and we pass in the parameters within our parentheses. Now if a function has a return value, you can also store it in a simple variable. Alright, so that's the basics of functions. Now let's learn about ifs and conditions. So it's very simple, you just write the if keyword, then you write your condition, and then you open and close a code block. So a condition is anything that evaluates onto a boolean. So you can do comparisons like this. So I less than 10. You can do greater than. You can do equal to, less than or equal to, greater than or equal to, and not equal to. So the exclamation point here means not. You can also call functions. So down here we have a function that returns a boolean. So we can also call this. And again, we can use an exclamation point to invert the result. Then you can also combine conditions. So mainly you do that with an AND, which is 2 ampersands, or an OR using 2 pipes. So here this whole thing will be true if I is under 10 and I equals 5. Then you can also group conditions by using parentheses. So here we are testing if I is under 0 and I equals 5, or I bigger than 10 and I equals 15. So first this one evaluates and this one evaluates, and then you evaluate the entire OR. So you write your condition and then you have the code block which runs if this is true. So in this case 5 is under 10, so if we run, yep, there you go, we have true. Then after the code block we can also add the else keyword and another code block. So this is what will return if the condition is not true. So here make this 15 set, so this will be false. And yep, there you go, we have our false. Another way of doing conditional logic is with a switch. So you do a switch on something, and then you have the various cases depending on the value inside here. So you write case, then the value on this case, then in here you write whatever code you want, and then you do a break to indicate the end of the case. You also have the special default, which is the code that will run if the value does not match any of the other cases. Then you have collections like arrays and lists. Those are data types that hold a collection of variables. So to define an array, you write the type of the array and then square brackets. So here we have an array of ints, and now by default the array won't be set to null, so we need to initialize it. And to initialize an array we do new of our array type, and in here we need to give it a size, so let's say 5. So we are initializing this array with 5 positions that can hold 5 ints, and all of those positions are set to 0, which is the default. You can also omit the size and initialize the array right in here. So just like that, we are initializing an int array containing all of these elements with these values. So this is our array, which is a fixed size collection. Now if you need something with a dynamic size, you can use lists. So you write list and then the type inside the angled brackets. And again, by default, this will be null, so we need to create the object. So we do a new list. And again, if we want, in here we can also initialize some variable. Now, the main difference between a list and an array is that the array is fixed, but the list can expand and contract. So here we can do int list and add a value. Then we can also remove a value. Alright, so these are your basic collections. Now let's learn about loops. The easiest way to cycle through a collection is with a simple for each. We do for each, then we write our iterator variable and then the collection that we want to cycle through. So this will cycle through the whole list and write it on the console. Yep, there it is, 1, 2, 3. So this works on any collection, so it works on the list as well as the array. Then you also have a simple for. So the for is split into 3 distinct parts. Each of them is separated by a semicolon. Now the first part initializes a iterator variable. Then we have our end condition. So if this is false, then the cycle ends. And the last part is run after each cycle, so usually this just increments our iterator. So we can cycle through our list count, which is going to count down the total number of elements. So in here we can do a simple write line to print the index position, and then the element inside that list in that index position. Yep, there we go. On index 0 we have the element 1. And then you also have a while. So you do while, then the condition, and then the code block. So this code block will run whilst this condition is true. So in this case, it will run 5 times. Then you also have a do while. The do while is very similar, except it tests for the condition only at the end instead of at the beginning. Now you can write comments in a single line with 2 forward slashes. Or you can do this to open or close comments. Now comments are useful for adding some text in your code. However, do keep in mind clean code principles. So ideally, your code should be fully and easily understood without any comments. If it's not, then go and rename your variables to make the code intent more clear. You can define your own types, and one of the more useful ones are enums. So you write the keyword enum, then the name. So this is an enumeration of certain specific values. So we have this variable of this type, meaning it can hold these possible values. For example, enums are extremely useful for doing a simple switch on a bunch of specific states. And C# being an object-oriented language means that you can create your own classes. So you write the keyword and then the name. Then you can create an object of this type by first defining the type, then the name, and then you do a new and you instantiate your object. Now by default you have a parameterless constructor, but you can also write your own. Just like that. And then inside your class you can do anything you like defining fields and functions. So just like that. Then something very important, which are accessors and scope. Now for accessors, you have mainly public and private. Private means that this function is only accessible from inside this class. So if up here I try to access that function, there you go, there's an error because that function is private. But if I swap it to public, now I can access that in here. And if you don't specify anything, like for example on this void main, then the default will be private. Now these accessors can be applied to functions, but also to all of these fields. So all of these fields are private, so I cannot go up here and modify them. There you go, an error. And now regarding variable scope, a variable defined inside a function only exists inside this function. So here we're defining an int variable named I, and then we are calling this function, and here we have an error because I does not exist whilst inside of this scope. It's defined here, so the variable only exists from here to down here. So in order to use a variable over several functions, you can define it up here as a member variable. And just like this, now we can use this same I down here. Alright, so that's the basics of C# in just 10 minutes. These are the absolute basics, so if you want to learn more, then check the playlist linked in the description where I cover.
Okay, so you went really fast. That's intentional. I wanted to keep you on your toes, so you were typing and going. Now, something else I want to mention. I'm a big proponent of repetition. Okay, which is to say that so anyone that's had me in any other class, because I'll use last Friday's game design as class as an example. We watched a video on the Sega 32X. Then we watched a video on Sega's 3 biggest gaming mistakes, or Sega's 3 biggest mistakes, and number one was the Sega 32X. There was a lot of information that was shared between the two. There was a lot of information that was exclusive to each of them. So I like to give you multiple perspectives. Okay, so we're going to see multiple people over the course of the semester do the same thing in different ways, do the same thing in the same way as each other. Do the same thing in the same way, but give two different explanations about why they're doing it, and different things like that. Okay. So here in just a minute, we're going to take a break, and then we'll come back, and what we'll do is we'll go over our exam, the first part of our certification exam for next semester, and we will also discuss what our project is for today. Now there will be either one or two little tiny projects. I haven't decided yet, but they'll be very, very simple, and they'll just be going over the basics of C#. But the main one for today is going over doing things with lists. Okay. Any questions, concerns, comments, thoughts, ideas? All right. Come back at 10 o'clock, and we will start working on our